What's good, Logan? All right, so section 3.6, quadratic inequalities. Your notes kind of look like this. So if you're thinking about setting up your notes, this is how it would look. Highly suggest not writing down the word part until you have extra time. Right now, really focus on the equations. But to go through the words parts, what we want to do is just kind of make sure we understand what's going on. So once again, this is section 3.6, quadratic inequalities. We're going to be focusing on today on two variable quadratic inequalities. So two variable ones. That means y and ax squared plus bx plus c. Now there's four different variations you can get. You can get one where you have greater than, less than, greater than or equal to, and less than or equal to. So that's going to be our focus. If you don't understand it, not a huge deal. We'll go through it. Right now, let's focus on the technique for graphing these types of problems. So if something looks like this right here, how would we go about graphing them? So the technique breaks down. Once again, don't write this down. I would focus on what it says and then, practice it. All right, so it says graph the parabola y equals ax squared plus bx plus c. You'll notice that the inequality is going to change to an equal. So instead of having this, right, instead of having those guys right there, you're just going to change it to an equal sign real quickly. All right, so we're going to graph that first, the equal version of it, where the line is dashed or solid. So it's either going to be dashed or solid. Now, it's dashed if you have less than or greater than. All right, so dashed if it's just less than or greater than. But it's solid if you have less than or equal to and greater than or equal to. Once again, solid if the little line is underneath the inequality. Remember that. That's step one to graph the outline. Step two, you're going to pick a point and then you're going to test it. Now, the point I would suggest is inside the parabola. Don't pick something outside the parabola. Pick something inside. If you feel like you can do the outside ones, go ahead. I'm just going to say I'm always going to pick something on the inside. Pick a point inside the parabola and plug it into the inequality. Third step is to interpret what that means. So what does it mean? Well, is it true or is it false? If it's true, we shade the inside of the parabola. But if it's false, we're going to shade the outside of the parabola. So once again, true, shade the inside because that's where the point was. And if it's false, shade the outside because the inside did not work for us. All right, let's put it in play. Now, when you're graphing these things, the two things you're going to want to be looking at, the first thing you're going to be looking at is whether or not the equation is in vertex form. Okay, for those of you that forgot vertex form is the one y equals a times x minus h squared plus k. Right, that's the vertex form. Now, in vertex form, once again, a times x minus h squared plus k, there is only one x in the problem. All right. Now, if you look at this problem, there's only one x. That means I think it's in vertex form. This one over here, I got 2x. I got that little straggler over there. I would say it's not in vertex form. This one here only has 1x. I'm thinking this guy is in vertex form. And then let's scroll over here real quickly. This one has 2x's. That indicates to me probably not in vertex form, so we're going to take a different strategy for those problems. So the first problem, like we said, is in vertex form. This is question number 1. The first thing we want to do is we want to identify what the vertex is. The way we identify the vertex, we ask ourselves, is anything being added or subtracted from the x value right there? If your answer is no, then we don't have any h value that's other than 0. So the h value is 0. And then, is there anything being added or subtracted at the end? And since nothing is, we know that our k value is also 0. So from this, we can say that our vertex is located at the point 0, 0. No shift right or left, no shift up or down. Then we have a stretch by 2. So we're going to stretch our function by a factor of 2. Well, let's go ahead and graph this thing. So it's a fairly straightforward graph. We're going to graph the y-axis, followed by graphing the x-axis. Now, since my graph is going to get stretched upwards, I'm going to make sure I have a little bit more value on the up and down. Then I plot the vertex. My vertex is located at 0, 0. After I plot the vertex, I'm going to go over 1, up 1 normally. Normally, these are the points that I would use. Over 1, up 1, over 2, up 4, right? 2 times 2 is 4. But because of the stretch, we have to do a little bit of manipulation of those points. So rather than going up 1 for those 2 points, we're going to double it because that's what that stretch does. So it doubles it so that it's at 2. Now, if I double the 4, right, the points that were over there, that would give me 8, and I ran out of space. So I'm not going to go ahead and double those points. I don't have enough space in my graph. Next, moving on, finishing off stage 1, we have to look at the inequality. Because the inequality doesn't have the line underneath it, we know that we're going to do a dashed or dotted line. So we have a dashed line because of the inequality. So we draw our dashed line. So we curve out We connect the points of our parabola. Remember, you're making a parabola, not a V, and you're going to do it so that it is a dashed segment. So the curve is dashed and not dotted. Once again, that has to do with the fact that there is no line underneath it. If the line was there, then it would have been a solid curve. Moving on to step 2. Step 2, what you want to do is you want to identify a point inside the parabola that you can test. Now, what I said earlier, or what I forgot to say, is that you want to pick a point that is on the y-axis. You don't have to, but you want to pick a point that is on the y-axis. Now, you want to pick a point that is also inside the parabola, so we only want to pick points that are in here on the y-axis. Now, some people ask why the y-axis. It has to do with the points on the y-axis, because at this point right there, this point, x is 0, 0, 4, 0, 3, 0, 2, 0, 1. However, we cannot pick a point that happens to be on the parabola. We need to pick a point that's inside the parabola. Those ones will not work. We don't want to pick points on the outside of the parabola. Primarily, we want to write a simple note, and the simple note is pick something on the inside. The easiest point for me to pick would be this one right here, if I can. So I'm going to pick 0, 1. So we're going to grab the point 0, 1, and we're going to test 0, 1. So we test 0, 1. Now we test it by plugging it into the original polynomial, the inequality. Y is greater than 2x squared. In the y value, we're going to place a 1, and in the x value, we're going to place a 0. So what we have is 1 is greater than or equal to 2 times 0 squared. Now we should know that 0 squared is 0 and 2 times 0 is 0, which tells us that 1 is greater than 0. And this is why we want to pick numbers on the y-axis. It gives us a very easy equation to analyze. Now, as we analyze this equation, what we notice is that the statement here, 1 is greater than 0, is true. And this moves us into our third step. If the point inside the parabola that you picked is true, then we are going to shade inside that parabola. So the parabola is going to get shaded on the inside. This right here, this graph, is the solution. There's not a single number solution. It's actually an infinite set solution, but we can't bound it between two variables because it's both x and y. So we're going to be using the entire graph to describe it. The short end of it is just graph the part that is true, and don't graph it if it's false. Graph the outside. All right, let's try this again. Let's take a look at number 2. Now on number 2, you'll notice that this one has y is less than or equal to x squared minus 7x, and we have an extra x value. What that tells me is that vertex form is not going to work. So the first thing I do, and I encourage you guys to do this all the time, is spend 15 seconds factoring. If it factors within 15 seconds, then that is the technique or style that you want to use. So we are going to go ahead and graph y is equal to x times x minus 7. So I am factoring out the GCF of x. Factoring out the GCF of x allows us to find our x-intercepts. X is equal to 0, and x minus 7 is equal to 0, using the zero product property. X is going to equal to 7 if I add 7 to both sides, and I now have my two x-intercepts, also known as your P and your Q, from the textbook. So we take our x-intercepts and we're going to graph these guys right here. So since our graph is going to be heavily focused on the positive side of the x-axis, I'm going to make sure that I have most of my focus, most of my problem on the positive side. So I graph my two x-intercepts, 0 and 1, 2, 3, 4, 5, 6, 7 right there. The next thing I want to do is I want to find out where my axis of symmetry is. Now remember, the axis of symmetry is perfectly in the middle of 0 and 7. Your x-intercepts 0 and 7, which happens to be somewhere right about there, or 3.5. Now for those that forgot how to find it, you take your x-intercepts, 0 and 7, and you add them together and divide by 2. This gives us 7 over 2. So right here is our axis of symmetry. Now the reason why the axis of symmetry is so important is it also gives us something to plug in to find our vertex. So we're going to take the 7 over 2 and we're going to plug it into our equation. So we grab this up. Right now we're still working on technique 1 where we're graphing the problem. So we're going to take the 7 over 2, which is our h, and we're going to plug it in to find our k value. So that's what we want to do right now is we want to find the k value. So we take it and we plug it in. We go y equals 7 over 2 times 7 over 2 minus 7. If you don't know what just happened, I changed the x's into 7 over 2. I'm plugging in the h value. Now, as I plug in the h value, what I end up getting is y equals negative 49 over 4 after you do all the simplifying. So my y value, or my k value, is negative 49 over 4. Let me tone that up a little bit. Let's see if I can thin that out. 49 over 4. And when I graph it, it would be somewhere, I ran out of space. I'm just going to put that point. All right. Next, we take a look at this. That tells us that we need to have a solid parabola. So I graph the solid parabola. Zoop, zoop. And I graph the other side of the parabola, making it not look like a V, but more like a U. And then I get to test a point. I can test any point I want. I'm going to pick something that's inside the parabola. The point I pick is going to always be on my y-axis because it always gives me an x value that's 0. Well, it looks like I can pick 0, 1 again, so I'm going to take 0, 1, and I'm going to plug it in. So I take 0, 1, and I plug it into the original equation, which is y. And a lot of this is going to get shaded out, I think. We'll find out, actually. Y is less than x squared minus 7x. And I'm going to plug in 0 for all the x's. 0 for that x, 0 for that x, and I'm going to plug in 1 for the y, because that's what it says. It says 0 for the x's and 1 for the y. I have 1 is less than or equal to 0 minus 0. 1 is less than or equal to 0. And I think about that, and I realize that that statement is just false. That statement does not make sense. So that tells me I can't shade inside the parabola. What I need to do is I need to shade the outside of the parabola. So I'm going to shade the outside region of the parabola. All the points on the outside will actually give me solutions that work. And this takes us through our third step of the technique of graphing quadratic inequalities. Moving on to question number 3. All right, so number 3, once again, we have something that looks like it's in vertex form. So first thing we want to do is identify what the vertex is. Some of you are like, how can you tell it's in vertex form? Right, remember, vertex form is the one where you have a times x minus h squared plus k. Once again, how many x's are in this? Just 1. And this has just 1. This tells us that we're in vertex form. All right, so we grab this problem here and we find where the vertex is. The vertex has not been shifted left or right because there's nothing being added or subtracted from the x value. Some of you say inside the parentheses. Exactly, there's nothing inside the parentheses. All right, so my vertex left to right, nothing, so we're going to be at 0. No change on the 0. But then up and down, this number here goes down 2, so we're going to say that we have a shift of 2 units down. So our vertex is located at 0, negative 2. Now, because it's negative a right there, we know that the graph is going to be going upside down. It's reflected. This graph is going to be reflected through the x-axis. So now I can set up my x and y-axis. So I set up my y-axis. And since I know it's going to be going down, I'm going to give myself a little bit more room on the downward part of the function of the graph. Next, I plot my vertex at 0, negative 2, which is located right there. Now, normally I'd go over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4, and my parabola would look like that. But because of that negative 2 right here, we're going to flip it and we're going to stretch it by a factor of 2. So instead of going over 1 and down 1, we're going to go over 1 and down 2. We're going to do the same thing to the left of it, over 1 down 2, and then we're going to look at the inequality and ask ourselves dotted or solid. Since it's dotted, I will draw a dotted parabola, and I have something that looks like this. Next, we're now going to pick a point. So stage 3 of the problem is to pick a test point. We're going to test a point. Generally, I always pick something on the y-axis, but because the y-axis up here doesn't work, it's not inside, well, it does, it's just not inside the parabola, I'm going to pick something down here. I want something down in the bottom part. So I'm going to pick the point at 0, negative 3. So I'm going to choose to test 0, negative 3. So we're going to test 0, negative 3. I'm going to plug it into the original function, the original inequality. Y is less than negative 2x squared minus 2. All the y values are going to get negative 3. There's only one of them. And all the x values are going to get 0. Well, that ends up giving me 0 plus 0. So now the question is negative 3 less than 0? Ooh, I just made a mistake. I'm sorry about that. You can't plug in 0 there. There's no x in that location. right? So you're not plugging in 0 there. You're plugging in 0 only for the x's. My mistake. That's 0 minus 2. And 0 minus 2 is negative 2. Oh, almost had a catastrophe there. All right, so now we have negative 3 is less than negative 2. Negative 3 is less than negative 2 is true. Now, for those of you that don't know, the way I would do it is I would say negative 3 is lower than, right? Negative 3 is lower than negative 2. So this statement is true. This is a true inequality. And this takes us through step 3 of the technique is we want to determine whether or not it's true or false. Now, this is a true statement, which means we are going to shade inside of our parabola. And that is our graph for question number 3. Okay, moving on to number 4. If I were doing it, I would probably pause at this time, but because you're probably watching this as a class, maybe keep going. But if you're watching this by yourself, pause it right now and see if you can do this one. If you get stuck at any point, hop back on and we'll go through it. All right, so here's how it goes. This one here is not in vertex form, that dangling 3, right? There's the x, there's too many x's. So what I'm going to use is I'm going to use a factoring technique. Please remember, try to factor. It's only 15 seconds. If it takes longer than 15 seconds, then obviously I don't want you to factor. Use a different technique. But I'm going to try to factor this thing. So the factors of x squared are x times x. So far that's 3 seconds. The 10, I have two options, 10 and 1 and 5 and 2. Most people try 5 and 2 first before they try the 10 and the 1. About 6 seconds in. Next, we multiply 5x and 2x. We're now sitting at about 10 seconds. And then the question is if it says minus there, we subtract them. When we subtract them, we get 3x. And we realize that we actually can factor this thing. So I'm going to go ahead and factor this thing through. I'm going to go negative 5, positive 2. This is the factored form of my quadratic, which means I can find my x-intercepts. You know what? Usually I write it as equal. So once again, if you can factor it in the first 15 seconds, it will save you quite a bit of time in the future. So we say x minus 5 is equal to 0, and x plus 2 is equal to 0, which means x equals 5 when I solve that, and x equals negative 2 when I solve that. So now I'm ready to move on to my graphing part. So what I'm going to do is I'm going to graph my x-intercepts in negative 2 and 5. That means I'm going to have a little bit on the negative side and a lot more on the positive side. So I'm going to draw my x-axis, and my y-axis is going to have heavier weight so that the right side has more value because there's an x equals 5 versus the x equals negative 2. So I'm going to graph the 5, 1, 2, 3, 4, 5 right there. And then I'm going to graph the negative 2 right there. So we got the 5 and the negative 2. Now remember, if this is a parabola, then you have an axis of symmetry, which is probably going to be somewhere around here-ish. Now let's be more accurate. You can't be that flimsy. So we're going to take our x, our P and our Q, our y, our x-intercepts, and we're going to add them together, and then we're just going to divide them by 2, which gives us 3 over 2. So we know that we're going to be located here in terms of our axis of symmetry, 3/2 or 1.5. Now we want to find where the vertex is, so we're going to take the 3/2 and we're going to plug it in. So I'm going to take the 3/2, this is my h, and this is going to find the k value. So to find my k value, I take my h and I plug it into the equation. 3 over 2 minus 5, and 3 over 2 plus 2. Now, for those that forgot how to add fractions with whole numbers, we got a common denominator. But what ends up happening is you get negative 7 over 2, because 5 is 10 over 2, and 3 minus 5 is negative 7. And 2 over 2 is 4 over 2, so we get 3 plus 4, which is 7 over 2. And when we multiply that, we get negative 49 over 4. So I go ahead and graph this, and it's going to be somewhere down here. All right, so there's my vertex. My vertex at 3 over 2, comma, negative 49 over 4. Next, we take a look at our inequality, and it tells us that we are going to want to make sure we do a solid parabola. So we graph a solid parabola, making sure not to do the dotted one. So we get the solid parabola. Okay, so it's like you're filling in the line. That's going to be an important idea in the upcoming section. So we're filling in the line so that there's no dotted or dashed regions. Next, what we want to do is we want to pick a test point. And you already know what test point I'm going to try to pick. I'm going to try to pick something on the y-axis. So I'm going to test this point right here at 0, 1, and I plug it into the original equation. So we're going to grab the original equation, y is greater than x squared minus 3x minus 10. And we're going to plug in 1 for the y value. So we're going to plug in 1 right there. And then we're going to plug in a 0 for that x value and a 0 for that x value. In other words, those x values turn into zeros. And then we have is greater than minus over there, minus 10 over there. In other words, 1 is greater than negative 10. There's also the equal, sorry, don't want to forget that. Doesn't really affect the problem right now, it just tells us whether or not it's solid or dotted. Is that true? Is 1 greater than a negative 10? Oh yeah, that makes sense. All positive values are greater than all negative values. So this is a true statement, which tells us that we can now shade the region that that point was in, and that was inside the parabola. All right, go ahead and take a look at the homework on Canvas. If you have any questions, hit me up by email or talk to me tomorrow. I'll be here after school, by the way, so if you wanted, you can stick by after school if I don't show up in the middle of class. But if not, I'll see you guys tomorrow.